Okay, for this topic we'll be using a graph paper, a ruler, pen so it can be more visible, a red pen, and maybe a pencil if it's visible. So let's start with this. Our topic for today will be vectors. What are vectors? How do we see vectors? How do we label vectors? What makes a vector? Okay, so let's go and see what is a vector. So I'm going to take this graph paper and fold it in half. That's one. And the reason why I'm going to fold it in half because it is just an introduction to the topic of vectors. So by folding it again, so I now have 4 sections that can make my vector examples, okay, for this purpose. So that's my graph paper, and I'm going to use a graph paper so it can be seen. So I'm going to put here my graph, okay. So I draw my line this way, and I draw another line, this way. I'm going to put an arrow in this direction and in that direction as well. So here we're going to be looking at vectors, okay. So this is the x-axis, this is the y-axis, okay. So what is a vector? How do we represent a vector? Okay, well, a vector, we can say it has direction. So let me write it here. It has a direction, it has magnitude, and another word for magnitude is simply length, right? So we can, length means also magnitude. So these are the two things for a vector. So let me draw a line. I'm going to start from the origin, which is at the center. So I take from here and I come in this direction. Okay, that's not too bright with that pen, so let me use the next one. Alright, so that's much clearer. And I'm going to put an arrow here, an arrowhead. This is the tail, this is the head. So that's a vector. The arrow shows direction. The magnitude, length, it simply means that you can take a ruler and measure its length. Okay, so it does have a length, it has a direction. So that's a vector. A vector can be in that direction, it can be in this direction, it can be in that other direction, okay. A vector can also be in this direction. Different size vector, different size lengths, but they have an arrow, a head and a tail. Now, not because I am showing you starting from this point means that vectors can only start from the origin. This is also a vector. You can put a vector here. That's a vector also. It has a head, it has a tail, has direction, has length. Same two properties as that as any vector. The vector can be in that direction, the vector can be in this direction, the vector can be here. So if you notice, the vector does not have to start from the origin. So all those are vectors. So let me draw next vector here. Let me draw next vector here. So notice that they're pushing, going out. But a vector can also go up in this direction. Okay, it doesn't have to be going out. Alright, so a vector can come down also this way. It has arrow direction, it has a tail. So I mean it has a head and it has a tail. So vectors have direction, magnitude, or length. Another word for magnitude is length. Why? Because you can take a measuring ruler or some measuring stick and measure that of a vector. Okay, so now let me bring this sheet of paper here so I can put my vector sheet, and I'm going to turn to another page so we can see that of our vector. Okay, I'm not going to use it because it might be too jumbled up. So I'm going to choose this other page here for us to describe our vector. So here we go. So let me do my vertical axis, okay, and my horizontal axis. This is for this purpose only, that I'm going to be doing it this way. All right, there we go with the arrows for the axis. So I'm going to draw a vector maybe this way. All right, so this is my vector here for simplicity and for easy explanation, and then we can go from here. We'll start from this point. So let's see how we're gonna label this vector. So I brought the white sheet here, so we do some labeling on the side. This vector will be given a letter V. That's how we're gonna be representing the vector, with an arrow on top. Notice the direction of the arrow, which goes now equal to, we're gonna be label its components, because it does have components in this vector here. Now as you can see, this vector, it goes from here in this direction. So I'm going to call here 1, 2, 3. This is 1, 2. So this vector goes 3 across and 2 upwards from this point to this point. So that's this vector here. So the components of this vector will be of 3 and 2. Okay, that is for the vector. So then this is 3, this is 2. Okay, so my component for this vector will be as follows. I'm going to put my bracket. I'm going to write my x component first, which is this bottom value on the horizontal axis, which is 3, and my y component, which is the 2. I'm going to put 2 here. This vector is comprised of 2 components. This is the x component. This is the y component. Okay, so those 2 components make a vector, right? So anyone who is to get this vector know exactly what to do. There is no way that they can go wrong. So long as they recognize the x and the y component, they can draw this vector. Okay, so that's a vector. So what about this vector? Well, vectors may also be written in the form of a column. This vector can also be written this way. You put 3 at the top and 2 at the bottom. The 3, the top value is the x component and the bottom value is the y component. So the components do not change. They're still the same. This is a vector and this is a vector. This is a 1 by 2 matrix. This is a 2 by 1. But we are talking in terms of vectors. Okay, for this purpose of our vector, that is what we have introduced, that a vector can come from the origin. For simplicity's sake, we start from here and go in this direction. So we count the x values and then we count the y values. Then we put the x value into our vector components, and therefore we can label our vector. Notice how we label the vector with a V with an arrow showing the direction it is going. It is comprised of 2 components. Okay, so then let's try another vector now. So I'm going to put my other vector in this direction here. I'm going to put it this way from here to this point. I'm going to draw my arrow here, and I'm going to mark my 1, negative 2, negative 3, and here we have 1, 2, 3, 4. The component of this vector here now, so let me call this a different letter. So let's call this U. You will get to understand that it's just a label. Is equals to, well, the x component is what you will write down first, which is negative 1, negative 2, negative 3. So you put your negative 3 here as the x component, and then you go 4, 1, 2, 3, 4. So that's positive 4. That is written that way. That is also welcome to be written in this direction, in this format, negative 3 and 4. Notice I'm not putting a fraction, I'm putting the vector component, which means the x and the y. So this vector is the same as this vector, this as this. Notice that how they can be written out. Right? So vectors can be written up in more than one way. They are represented on the graph paper. Okay, so we have done the vectors. So let's see. We're going by its definition. Remember, we had vectors have direction and magnitude or length. So let's go with this information. Let's go with direction first of all. Do vectors show direction? Well, yes, because if you notice this one here, it said you got 3 to your right and then 2 upwards. This next vector said you got 3 to your left and 4 upwards. So it is showing direction. So this is to show direction. Okay, so that is for a vector. Now let's see, how do we know now its length of a vector, or the magnitude of a vector? Well, let's see, we have this vector here, and as you can see, this vector has formed a triangle. So that is what we will be using. I'm going to use broken lines. Okay, and notice here that this is 2, this here is 3. So I'm going to pull this information to the side and see what is it that we have. All right, so let me put this here and bring back what we ended up with. I have this triangle. That is 3 units here, 2 units here. That was definitely a right angle. Now, how do we find the length? Remember, this is the length that we want now, the magnitude. We're here, regardless of what direction it is going, it is just find the length. Well, recall Pythagoras' theorem. Pythagoras theorem. It says that the square of the hypotenuse is equal to the sum of the other 2 sides square. So let's call this, I'm going to give this the letter v for the vector, and so I'm going to put that the v squared is equals to the 3 squared plus the 2 squared, because that's Pythagoras' theorem. So therefore v is equals to the square root of 9 plus 4. All right, and this now gives me vector is equals to the square root of 13. We may leave it in that form, but if you have a calculator, then I am encouraging you to go to calculator and find your vector, which is the square root of 13. That gives us 3.6. So you put here vector is equals to 3.6 centimeter 1 dp. Ensure to state your amount of decimal places that you are rounding off your vector. Okay, so this is having taken out as a triangle, but since we are working with vectors, the way I want you to use is proper notation for getting our vectors. So if you were doing this working here from the graph, I just followed this so as to show the Pythagoras theorem how it applies. The way you're going to write it out is as follows. You're going to take your working and you're going to say double line at the top, vector, which means this means the length, and you are going to square is equals then to the other 2 lengths of the vector. Okay, so all the rest steps proceed the same until when you end up to the end. Remember, you put the arrow, you put here v arrow length, because this symbol is for length. Okay, so you end up with 9 plus 4, which is square root 13, and so we end up with the same value. Okay, so that's how you're going to find the length of the vector. Direction of a vector is because of this, length of a vector because of this. Okay, so we have 2 things on vectors. Direction, how do we know a vector has a direction? Because this is telling me the first component is telling me in how to move. This is telling me go -3, as in this graph paper. Go -3, go 3 to your left, then 4 upwards. This is telling me go 3 to my right and 2 upwards. Okay, so this is how you can understand that the vector has a direction. And now its length, well, we apply Pythagoras theorem. I use this so as to show that it is Pythagoras theorem. But when we are working with vectors, I want you to use this symbol to show the length of the vector. Okay, so this is going to represent the length of the vector. All right, that is for vectors. Okay, so this is with respect to this vector. Now let's do this one here that has a negative value, this vector here. So again, the concept doesn't change. I want you to write it this way. this vector, we said it's u, okay, and so we're gonna put here that the u vector, you put the symbol for length, okay, is equal, you must put the square sign here because it's Pythagoras theorem, and you put the length on your x-axis, which is -3 squared plus 4 squared. This now gives me 9 plus 16. Okay, so that's our vector there, our length, I mean. So you put that way, I put square root 9 and 16, that gives us 25, which is 5. So therefore the length of this vector is equals to 5. It has direction, it has magnitude. So we have completed that with that particular vector there. Okay, so these two vectors we did from a graph, but what about if we are given a vector, for example, y? That's our vector for right now. Okay, so let's put here y. We say that this vector is 8 and -6. Okay, so how do we find the length of that vector? Well, we do know that this vector has a direction because it is telling me how to go 8 on your x and -6, which means downwards on your y. So but what we want is the length. So what you will do is that you will put your vector this way. Again, the symbol doesn't change. The square sign is equals to the square root of 8 squared plus -6 squared, and then that gives us 64 plus 36, which is then equal to a square root of 100, which is 10. This is our length of that particular vector. Despite we did not get to see it on the graph, we don't need to see it on the graph. We can still solve for its length, and we do know it has a direction because it's telling me how to go about to get to this vector. Okay, that is if you're not given a graph. So in summary, we can say that a vector can be represented in this form here by having an arrow, a head, a tail. This is the x component, this is the y component. We can write the vector in this form or in this form, and we can find the length of the vector by using Pythagoras theorem. Okay.